particle P moves in a straight line with velocity function v of t is t squared minus 10t plus 24 meters per second. Find the times when P reverses direction. For something to reverse direction, it actually needs to stop instantaneously at a point. So we're looking for when v is equal to 0. And that gives me t squared minus 10t plus 24 is equal to 0. We can solve that by factorizing. So I've got t minus 6, t minus 4 equals 0, giving me t is equal to 4, or 6. Now, sometimes you'd need to check that it actually does reverse direction, because something can go along, stop at a point, and then continue to go in the same direction, just like you do when you're sitting in traffic, for example. However, this is a quadratic, and for something like that to happen, your graph would need to have a point of inflection, and quadratics are always either this shape or this shape. They don't have points of inflection. Find the distance P travels in the first 8 seconds of its motion. Okay, you can do that with an integral between 0 and 8 of the modulus of v of t dt. You can do that straight on the calculator. We're going to look at how to do it without the calculator. So, starts at t equals 0. And then it's going to go this way until we get to t equals 4. And then it will go back a bit until t equals 6. And then it's going to go in this direction until t equals 8. We just need to know those distances. So we know that s of t is the integral of t squared minus 10t plus 24 dt. So that is going to be t cubed on 3, take away 5t squared plus 24t, plus a constant, but we'll just take that constant to be 0. And we'll just say that we start at O, since the question didn't actually tell us anything about that. It doesn't make any difference to the distance travelled or the change in displacement, and therefore we may as well just take that equal to 0. So when t equals 0, it's 0. T equals 4, so we want all of these values. So s of 0, s of 4, s of 6, s of 8. And that's just a case of substituting into the formula. So I'm just going to do the values 0, 112 on 3, 36, and 128 on 3. So this distance here is 112 on 3. We know that that distance there is 36. And so this distance is 112 on 3, take away 36, which is 4 on 3. And then in a similar sort of way, we can get that this distance here is 20 on 3. And therefore the distance travelled is 112 on 3 plus 4 on 3 plus 20 on 3. And that gives me 136 on 3, or 45.3 recurring meters. Find the change in displacement from P in the first 8 seconds. Well, that is just simply this value, because s of 0 is 0, change in displacement is 128 on 3 meters.